Hydration needs are influenced by the environmental temperature and humidity. So as the humidity increases and the temperature is also elevated, hydration needs are increased. The primary way that the body maintains body temperature during exercise is via sweating. And as we lose heat through our sweat, the way of actually getting that heat loss is through evaporation of that sweat. And so when the air quality is humid, there is a lower chance or a lower likelihood of evaporation to occur. So as the humidity rises, that sweat just drips off. Well, that doesn't help to dissipate the heat. It just is a fluid loss without the heat loss from metabolism. And so there's a real difficulty with dissipating heat, which is going to result in detrimental performance and also danger. When an individual is in the process of acclimatization, which takes about two full weeks for that to occur, the individual will have an increased sweat rate, the plasma volume will increase, and a person will start sweating at an earlier threshold. So they end up sweating more quickly, they sweat more, and they also sweat less dilute sweat. So there's less sodium in that sweat. It takes 2 full weeks for acclimatization to occur, and that's why it's important for athletes to get to experience the temperature and humidity of the environment before performance, before the event. And there's a video in e-learning that I just posted that has an example of an athlete having heat injury associated with performing a marathon in an extremely unusually hot and humid environment. Altitude and fitness level of the athlete also influence the need for fluids. And what you'll see on the right is as the barometric pressure changes with altitude, there's less oxygen available, and as the thinning of that oxygen occurs, you have an increase in heart rate to kind of be able to get that exchange to happen more readily. So you have an increase in heart rate that occurs with that. And so the thinner air poses a greater metabolic burden on the individual. The cold environment in the high altitude environment scenario on the bottom indicates that when someone is in altitude, the environment is typically really cold. So you end up having initially the regulation of body temperature is impaired because of the increased demand for oxygen. You'll actually have metabolism ramped up. Muscle glycogen is depleted much more readily, and you end up having a greater loss of fluid from the respiratory tree, and that's that insensible amount. So that increases the water loss, and so the water requirements are also increased. A person has less thirst response from that, less appetite response, and they can go into dehydration very quickly. So we want to look at altitude and also the fitness level of the athlete in terms of athletes who are acclimatized. They sweat more readily, they sweat more dilute sweat, and they sweat more, which is going to change their water requirements. So how much should a person consume prior to either exercise, training, or performance? Well, we always want to make sure that we train to replicate what the practices that a person going to have when they do their competition. So you ideally want to have a good hydration status and meet your hydration needs or fluid needs before at least 24 hours the day before. 4 hours before, you want to try to top off your tank with 400 to 600 mils or 2 to 3 cups of fluid. 2 hours before, you can drink a little bit more fluid if you're not producing urine. And 10 to 15 to 20 minutes before, about a cup of water is a good place to start. So you want to start hydrated. You want to make sure that you're able to perhaps top off that tank 4 hours before, and 10 to 20 minutes before, have about a cup of water, and that will get the athlete started out in a good position. What should you drink? Well, it has a lot to do with what a person likes, the palatability. Sports drinks have pluses and minuses. The best thing about sports drinks is that if they're the right sport drink for the athlete and they've been practicing with it, it does have a little electrolyte in it, and especially if you're exercising intensely over 45 minutes, then a sports drink is going to be helpful because it has that small amount of carbohydrate and also can possibly make it more palatable for the individual to consume. If you're in a hot and humid environment, you might want to definitely you might want to have a little bit more. Your fluid needs are increased, and if it makes it more palatable, that's good. You want to avoid carbonated beverages because they give a sense of fullness that might actually discourage consumption of fluids. Juices are going to be too problematic for gastric emptying during exercise, and so you definitely want to limit that during exercise. Before exercise, I wouldn't recommend it too close to exercise. It's just going to mess with the gastric emptying, and that could cause some gastric upset. During exercise, I mentioned gastric emptying a few moments ago. In terms of gastric emptying, or the rate of fluid emptying from the stomach, it really is influenced or impacted by the volume and the composition of the beverage that's consumed. Large volumes empty at a faster rate than small volumes, and when athletes skip that fluid station, they're at an increased risk of dehydration and poor performance. So our goal is to maintain hydration, maintain electrolytes. If it's a very long duration activity, having that sport beverage is going to be helpful. If you can take about every 15 minutes, getting about a cup of water in, if you throw it on top of you, it doesn't work, but it needs to be consumed. During exercise, depending on the duration of the exercise and the heat and humidity, if you're over 45 minutes, a sport beverage is going to be really great. The taste is potentially going to be influenced by the electrolytes in that solution. And so as you look at the example that I have, we have a small amount of sodium, 150 milligrams of sodium that's in this particular beverage. And in this blue raspberry cherry, it's going to give it a little bit more palatable taste. That's going to encourage a person to drink. So that's where that sport beverage might be beneficial. If the practice or event is longer, we want to make sure we get a sport beverage. We get that carbohydrate and electrolyte. That's going to help with energy and also to help to maintain the or decrease the likelihood of someone having a low blood sodium level or hyponatremia. We don't want to have fruit juices because those are going to slow down gastric emptying. They're way too concentrated for carbohydrate, and they're going to cause cramping and discomfort. The association to determine, or the way to determine what the percent carbohydrate the beverage is to take the grams of carbohydrate and divide it by if it's a cup, if the serving size is 8 ounces, 8 ounces is equivalent to 240 milliliters. And then we convert it to a percent by multiplying times 100. So this particular equation works great if you look at the serving size, the amount per serving, and you want to use grams and milliliters to get your percent. So in this example of blue raspberry cherry, you have 21 grams of carbohydrate, and notice it says 7% of percent daily value. We don't want to look at that as our percent concentration of carbohydrate in this drink. We just don't want to make that association. We take 21 grams, and if we look at the label, it says it's 12 fluid ounces, not 8, and 12 fluid ounces is 360 milliliters. So 21 grams divided by the serving size of 360 mils, and then to convert it to a percentage by multiplying that value by 100, we get 5.8% carbohydrate solution. So this particular one, if we round it, it's about 6% carbohydrate solution. This would be an acceptable beverage. You also notice there's a little bit of sodium, and the sodium is abbreviated by Na. The sodium is, and that's where you get natremia. The sodium is one component that's going to add to the taste. I know that when I add a little salt to my food, it makes it more palatable. So one thing that sodium does is make that beverage potentially more palatable, but it also encourages a person to drink as well. So it's got a couple purposes. It's also going to be beneficial to keep the person at a lower chance of having low blood sodium, which would be hyponatremia. To keep a person hydrated during exercise, you want to always have fluids available. Encourage individuals to drink every 15 minutes. Take about one gulp. One good gulp is an ounce. So if they take 8 good gulps, they're getting about a cup of water every 15 minutes. So that's a good rule of thumb. Frequent breaks. Start drinking early. Don't pay attention to thirst. And cool drinks are emptied and also more palatable than warmed ones. So it doesn't have to be ice cold, just cool. So cool fluids are better than warm ones. So having a cooler with your beverages, having ready access, and having your athletes have their own personal water bottles make a good practice. And we want to be hydrated all the time. There's a couple gaining the performance points. Here we have 7 to 10 ounces every 15 minutes, and as I mentioned, 8 good gulps. 8 good gulps is about 8 ounces. That'll give you a good rule of thumb. And also, a person should not end up heavier after their exercise session. They either want to be the same weight or less, and not extremely light, because that would indicate that they weren't hydrating sufficiently. But gaining weight is definitely a problem, because a person might be at a risk of having low sodium in their bloodstream and have complications associated with hyponatremia. And emia means blood. Nat is the abbreviation for sodium, and hypo is low, so low blood sodium. Wanted to show you this real quickly with how frequent, or the exercise associated hyponatremia, EAH, occurs with frequency. And you'll see the first column is swimming, and less than 20% of the time a 26-kilometer open water can have hyponatremia, but at a much lower rate than the 161-kilometer mountain activity or 60-kilometer mountain activity. And here you have I did a sport, 100-mile I did a sport, or a extremely long duration. And you also see the Ironman Those are different data points from different research studies, which are identified as A, B, C, D, all the way through T. So it gives you an idea about where these occur. It's in those ultra running sports or multi-heavy Ironman type activities, and also in individuals that are not acclimatized. That's really important as well. Post-exercise, you want to rehydrate as soon as possible. Within 2 hours post-exercise is going to assure optimal post-exercise rehydration. You want to get in drinks and beverages and foods that have carbohydrates in them to help to restore that glycogen that's been utilized. Sodium, not a heavy sodium for the average individual, but sodium is also going to improve palatability. Have those beverages ready. Shouldn't be beer, but there's a beer mug right there. Avoid drinking a lot in a short period of time. So we're looking at drinking it over a period of time, not just drinking a liter of water immediately. You want to pace yourself, put some food in the belly as well. That's going to alter or impact the gastric emptying so it doesn't cause the dumping into your bloodstream real quickly. So here it is, 2 to 3 cups of fluid for every pound that's been lost. And I think this is a really nice chart which gives you a rough estimate of what type of fluid need is associated with a body mass loss. So in kilograms or in pounds. So here we're looking at the kilograms pretty much equals the liters, but most of our scales don't have kilograms, they have pounds. So this gives you an easy way of looking at it. And also this Corey Stringer Institute is a nice link. I think I'll put that on up for you. That's associated with Corey Stringer, who died due to dehydration as a football player. So it's a great resource as well.